Artificial intelligence, a journey from imagination to everyday reality. Artificial intelligence, the phrase that resonates in laboratories, businesses, and homes today, began as a dream woven from myths and equations. In essence, it is the ability of machines to perform tasks that, until recently, required human intelligence, learning from experience, recognizing patterns, making decisions, and even creating. But its history is not just a succession of algorithms and circuits. It is a tale of ambition, epic failures, and reinventions that have transformed our relationship with technology. It all began in the mists of the imagination. The ancient Greeks spoke of Talos, a bronze giant who protected Crete, and medieval alchemists dreamed of homunculi, artificial beings. But the real starting point came in 1950, when Alan Turing, a British mathematician who cracked Nazi codes during World War II, posed an uncomfortable question. Can machines think? His article, Computing Machinery and Intelligence, not only proposed the famous Turing test, where a machine must convince a human that it is another human, but it also sparked a revolution. In 1956, during a conference in Dartmouth, USA, a group of scientists, led by John McCarthy, who coined the term artificial intelligence, gathered to explore how to create machines capable of simulating intelligence. They were optimistic. They believed that within a decade, general AI, that is, an artificial mind with human abilities, would be achieved. But they soon faced the harsh reality. The computers of the 1950s, with their limited power and memories the size of closets, could barely solve basic problems. Even so, pioneering projects were born. Eliza, a chatbot from the 1960s that simulated a psychotherapist, or Shaky, the first mobile robot that could analyze its environment. The 1980s brought a new approach, expert systems, programs that mimicked the knowledge of specialists in fields like medicine or geology. Mycin, for example, diagnosed bacterial infections with accuracy comparable to doctors. But these systems were fragile. If the situation deviated from their programming, they failed miserably. The lack of adaptability, coupled with broken promises, led to 2 AI winters, periods of skepticism and funding cuts that lasted until the late 1990s. The Renaissance arrived with the new millennium, driven by 3 forces: data, computing power, and algorithms. The internet generated massive amounts of information. Graphics cards, GPUs, made it possible to process it at previously unthinkable speeds, and new machine learning techniques gave machines the ability to learn for themselves. In 2012, a milestone paved the way: AlexNet, a neural network that won an image recognition competition with revolutionary accuracy. It was proof that deep learning, deep neural networks inspired by the human brain could solve complex problems. The 2010s saw AI infiltrate everyday life. Assistants like Siri and Alexa became commonplace, Netflix and Spotify's algorithms learned our tastes, and self-driving cars began plying the roads. But the most iconic moment came in 2016, when AlphaGo, a Google DeepMind system, defeated the world champion of Go, an ancient game considered more complex than chess. The machine didn't just win. It did so with creative moves that baffled experts. Today, AI is no longer a passive tool. With the emergence of generative AI, machines don't just analyze, they create. Models like OpenAI's GPT for write essays, solve math problems, and hold fluid conversations. DALL-E and Midjourney generate realistic images from textual descriptions, while tools like GitHub Copilot write code as if they've had decades of experience. These advances are based on architectures like transformers, which process language and images by detecting patterns in millions of examples. In medicine, AI is saving lives. AlphaFold, another DeepMind prodigy, predicts protein structures with an accuracy that accelerates drug development. Algorithms diagnose cancers from X-rays with accuracy rates comparable to expert radiologists, and projects like the startup in silico medicine use AI to design drugs in months, not years. In agriculture, drones with sensors optimize crops. In the fight against climate change, models predict natural disasters or design materials to capture CO2. But this power comes with profound dilemmas. The same algorithms that recommend movies can perpetuate racial or gender biases if trained on flawed data. In 2018, for example, an Amazon recruitment system was found to discriminate against women because it relied on historical resumes from a male-dominated industry. Artificial intelligence also poses existential challenges. Deepfakes, hyper-realistic fake videos, threaten to erode trust in institutions, while automation could eliminate millions of jobs, especially in routine sectors. Faced with these risks, governments and organizations are seeking ethical frameworks. The European Union is leading the way with regulations that classify AI applications according to their danger, prohibiting uses such as indiscriminate facial recognition. Meanwhile, researchers like Timnit Gebru and Joy Buolamwini, founder of the Algorithmic Justice League, advocate for transparent and audited AI. Even giants like OpenAI and Google have implemented safeguards to prevent their models from generating harmful content. The future of AI is a canvas of possibilities and unanswered questions. Will we ever create artificial general intelligence, AGI, a machine with human consciousness and versatility? Experts like Yoshua Benjo believe it's still decades away, but others, like Elon Musk, urge us to prepare for the risks. Meanwhile, quantum artificial intelligence, the fusion of algorithms with quantum computing, promises to solve problems that are currently intractable, such as room temperature superconductivity or the design of clean energy. On this journey, perhaps the most remarkable thing isn't the technology itself, but how it's redefining what it means to be human. AI forces us to rethink creativity, privacy, and even ethics. It reminds us that, while machines can mimic our intelligence, wisdom, that blend of empathy, morality, and context, remains the exclusive province of the human mind. So the real challenge isn't building smarter machines, but ensuring that their evolution reflects the best in us: curiosity, compassion, and an unwavering commitment to the common good. Artificial intelligence is no longer science fiction. It's a mirror that reflects our capabilities, our prejudices, and our hopes. And like any mirror, its value lies not in what it shows, but in what we choose to do with that reflection.